Weather and climate, two elements that define every facet of our existence. Climate change affects our health, our livelihoods, and the very future of our planet. Human activities have triggered significant changes in the global climate system. Understanding these shifts is crucial for preparing ourselves and future generations.
2007, the Honorable Minister for Science and Technology and Earth Sciences recommended the establishment of a specialized center dedicated for understanding climate change. Eventually, in 2009, this led to the approval of the establishment of the CCCR, that is the Center for Climate Change Research, at the Indian Institute of Tropical Meteorology by the Ministry of Earth Sciences under the Global and Regional Climate Change Program, the 11th five-year plan.
Over the past 2 years, it's my privilege to look after the duties of Project Director of the Center for Climate Change Research and continue to support the significant scientific accomplishments achieved by the CCCR scientists and researchers under the leadership of Dr. R. Krishnan, Director IITM.
The CCCR quickly became the hub of innovation and research, contributing to national and international climate studies. One of its key achievements was the development of India's first Earth System Model, IITM ESM, contributing to the prestigious Intergovernmental Panel on Climate Change report.
Earth system models are important tools that integrate the interactions of atmosphere, land, ocean, cryosphere, various Earth system components that enable us the assessment of regional and global climate change. The IITM Earth System Model first version was developed in 2013 and subsequently in-house development has been carried out to achieve a radiatively balanced framework for addressing the long-term climate change over the region. At present, the next generation IITM ESM is being developed indigenously at CCCR at a higher resolution, which will provide us deeper insight into the climate variability and change and also help us understand the challenges of climate change we face over the Indian region.
CCCR led the preparation for the first climate change report for the Indian region from Ministry of Earth Sciences. This open access book, Assessment of Climate Change over the Indian region, discusses the effect of human-induced climate change on the Indian subcontinent, regional monsoon, the Indian Ocean, and the Himalayas. The CCCR also leads South Asia's contributions to the World Climate Research Programme's Coordinated Regional Climate Downscaling Experiment, providing valuable data to enhance regional climate resilience. Model outputs published on the Earth System Grid Federation, Cordex Data Node via the CCCR IITM Climate Data Portal are being extensively used by state government planning boards and disaster management authorities for preparing regional climate impact assessments and reports.
Greenhouse gases monitoring program started in 2009 at Sinhagarh, which is near Pune, and currently we have a site at different locations. For example, at central India near Bhopal, where we have a 72-meter tall tower where we are monitoring different greenhouse gases such as carbon dioxide, methane, and various other parameters. Also, we are monitoring the carbon fluxes. And under the MedFlux program, we have tower at Kaziranga National Park where ecosystem exchange is studied. So we are measuring carbon fluxes using eddy covariance technique. Other than this, we have observation at mangrove forest site at Pichavaram. This is near Tamil Nadu, where we are monitoring the greenhouse gases such as carbon flux and methane. And we have observation site in Nainital, where we are measuring carbon flux in forest ecosystem.
CCCR began soil moisture observations in 2017, using cosmic ray soil moisture observing systems to study soil hydrology and its role in land-atmosphere interactions, advancing the science of climate change. Understanding the past is key to predicting the future. The Paleoclimate and Dendroclimatology Research Group at CCCR studies past climates, dates historical events, and analyzes natural disasters like droughts, floods, glacier retreats, and volcanic eruptions using tree rings to offer data beyond instrumental climate records. The group also uses Paleoclimate's limestone cave deposits to reconstruct the Indian monsoon precipitation for the Holocene period. It has produced high-resolution rainfall data of the Indian monsoon for the last 3,200 years. Recently, the group established protocols and lab setups for trace element analysis in speleothems to study and link environmental changes to historical human habitation and migration. The Water Isotope Research Group at CCCR studies the role of hydrometeorological processes on water isotope values across India and their effect on climate reconstruction. They have recently begun water isotope modeling activities for improved climate modeling.
My group do research on atmospheric chemistry and climate using observations and model simulations. We use highly specialized balloons to measure ozone, water vapor and aerosol backscatter at the high altitude region, that is up to 30 km, at the southern slopes of Himalaya, that is at Nainital, and in central India at Bhopal. These measurements help us to understand transport of gases and aerosol to long distance, variability of ozone, water vapor, cirrus cloud and related climate change. In addition to these observations, we use chemistry climate model simulations to understand the climate change globally with a focus on the Arctic region.
Alongside climate observations, research on measurements and modeling of atmospheric chemical species is also carried out at CCCR IITM. Over the past decade, the Atmospheric Chemistry and Climate Group at CCCR has measured reactive trace gases in different environments. This work has enhanced the understanding of these trace gases and their impact on the Earth's radiative budget, both directly and by altering levels of short-lived climate forces. These observations are conducted globally, extending to remote regions such as the Arctic and Antarctic. Beyond research, the CCCR plays a vital role in capacity building, offering training and outreach programs to stakeholders, scientists and students, helping to shape the next generation of climate experts. As we look into the future, CCCR continues to innovate. The Institute has established the Climate Data Archival and Distribution System (CDAS) to disseminate climate change projections using the IITM Earth System model developed in-house at IITM Pune. Inaugurated by the Honorable Secretary of Ministry of Earth Sciences in August 2024, the CDAS server is designed for large-scale data management, enhancing climate research capabilities in India and abroad. Supercomputers play a vital role by providing enhanced computing power to run the Earth System Models (ESM) for generating climate change projections. For performing climate projections using ESM and to analyze huge amount of data from the ESM, supercomputers are necessary. The climate projections using IITM ESM and regional climate change projections at CCCR are carried out using high-performance computing system at IITM. The CCCR building is recognized as one of India's non-conventional, energy-efficient and eco-friendly thermal active building or green building. Certified by the Ministry of Earth Sciences in 2012, it employs radiant and evaporative cooling systems to promote energy efficiency and sustainability. A remarkable milestone for CCCR came with the prestigious recognition of Dr. Roxy Matthew Cole, who was awarded the Vigyan Yuva Shanti Swarup Bhatnagar Award 2024 under the Rashtriya Vigyan Puraskar by the Government of India.
Over the last 15 years, I am very happy that CCCR has evolved into a truly outstanding center for addressing all the key aspects of global and regional climate change scientific issues.
Our climate is changing, and the work done at the Center for Climate Change Research is critical to understanding these shifts. As the world grapples with the effects of climate change, CCCR stands at the forefront, guiding India and the global community towards a more resilient and sustainable future.